Hey guys, Will and Basil here with Grayson Hobby, and today we're going to talk about a build video that we're going to be doing. This is the first part of our build video. This is going to specialize over the OX 215 frame from OX FPV.
Right.
And also the CL Racing F4S.
This build video is going to go over everything from how long the wires have to be, how long the standoffs have to be, where you solder the wires, how you solder the wires, everything from the basic opening the box to configuring the Betaflight.
Yeah, as long as you know how to solder, that's the key thing. This is a build you're going to be able to do without really any knowledge. I'm trying to make it to where it's kind of a step-by-step how-to build on this particular frame that we're going to be offering. And all the tools we have are nothing fancy. We're using some adjustable wrenches, some yeah, I was trying to use
soldering irons,
bare bones, X-Acto knife, soldering iron, wire snips, wire strippers, stuff like that.
Right, so nothing fancy here. And the cool thing is everything that you see here will be listed. We're going to have a one big package deal where it has everything, the screws, the nuts, the bolts, the receivers, everything. You have to just select the FreeSky receiver or the Spectrum receiver, and you're good to go.
Everybody's been asking, hey, I want a quad, but I want to build it. I hear it so many times. So hopefully this video will kind of give you a little bit of insight on getting something going. And hopefully, if a bunch of people get it, we're going to have a little bit of a community that everybody can bounce ideas and stuff like that.
Now the OX frame is very durable.
Yes, it's extremely durable.
Put it in crash here. And it's non-conductive.
Yes, so the frame itself, unlike a carbon fiber frame, you don't have to worry about shorting out the ESCs on the arms, stuff like that. The motors are very well protected from the actual material itself, from the arms that go around it. So it's built very nice, it's very durable, very easy to build, and very, I guess you'd say forgiving as far as for usage and all that. I've beat the crap out of mine and it's been going. It's built like a little tank, I guess that's why they call it OX frame, right?
So this is Will's personal one. How long have you been flying this one?
I've been flying it, God, it's been a couple months.
Right, so all the components mesh together, they talk together, play well, nice with each other.
Yeah, this is all based off setups I've used before.
Right. Alright, so we'll list all the tools you need, gather your tools, get the link below for the complete build, and here is step part one.
This is a really quick build. This flight controller makes everything easy. The frame makes everything is easy. So you take an easy build frame and an easy build flight controller, and it just makes it a really quick build.
Alright, so what you got here, Will?
All right, so what we got here is pretty much all our components laid out. We got our ESCs, we got our motor, we got our flight controller, we got the VTX, we got an antenna, we got a pigtail for the battery connector. We have the motor screws that comes with the aux frame. We got a receiver. We're going to pick one of these receivers. We'll get to those later.
Separate video on
yeah, there'll be a separate part on that because there's 3 different versions, whether you use FlySky or Spectrum or Taranis. We got our camera here as well. We're going to use the the mini Swift on this one here.
Alright, so flight controller and then
yeah, this is the Mateck VTX. This is the Mateck selectable one. This will give us the ability to program and all that through the on-screen display.
Alright, what ESCs we got right there?
These are SpeedX ES20s.
Right.
The SpeedX are pretty rock solid.
Gotcha. And last but not least, the motors.
Yeah, these are the 2300 kV Brother Hobby Returner R2 style.
Alright, so that kit is already on the website. So, alright, what is the first step?
Well, first step is to take the factory frame, and we kind of have to disassemble a little bit. We're going to take this top plate off. So there's 4 screws here.
Alright,
I'm not even going to take the screws out of the plate. I mean, they're in there, but I'm just going to move it aside for now.
Okay.
The next thing, these standoffs that come with them, these are actually going to be a little taller than what we want. But with the newer flight controller that has the soft mounts built in, we're actually going to get rid of that. So we're going to take those out here.
Alright, all out.
Alright, so I got these 4 screws, and I'm just going to put these screws aside for later. So what we're going to need to do is cut the motor wires here. This is going to be roughly about 30, I believe it's 25 millimeters of the wire, and then add about 4 millimeters worth of the exposed wire to solder to the tabs. So we need about 29 millimeters of wire here. So what we're going to do here is we're going to actually take the motor, lay it up against the ruler, and measure out about 29 millimeters, and then cut the wire off. And then we're going to unshield the about 3 or 4 millimeters there, which will give us the ability to solder onto the. So we're going to lay it out here. And usually what I do, alright, so there's our 25 plus 4. Kind of mark there, and then I take my wire snips. Once I get it laid out,
Once you mark it, right?
Yeah, I just kind of marked it with the with the X-Acto instead of tearing up the X-Acto, and then just cut it across there. And then if you have a wire stripper, great. If not, you can use an X-Acto and just lightly run through the silicone. But then we're going to take and if you look, you'll see the solder pad is only so long. That's all we need. We don't need a ton. You don't need to make it, you know, an inch long or anything like that. So we're just going to do a couple millimeters of exposed lead. Oop, wrong one. Alright, so we're going to strip the wire there. So we got that, and then we're going to repeat that for the other 4 motors. In this particular build, since everything's symmetrical, it's easy just to measure everything out, cut it all, tin everything, and then do all the soldering at one time. It kind of speeds up the process, kind of like assembly line style. Alright, so we got the 4 stripped there, and we're going to put those aside for now, and then we're going to tin them later. Now the next thing is the speed control. We're going to cut down the leads for the speed control. The length we're going to want, I've actually cut this one so I know the measurement here, but they come pretty long, and I'm going to leave a little extra wire so it can maneuver inside the frame. It's not going to hurt anything, and it gives you the ability to solder and move and all that down the road. But what we're going to want is the edge of the board here at the back. And then we're going to want, let's see, what did I get here? About 45 millimeters with a couple millimeters extra for the actual solder pad. So it looks like we're about 43 millimeters total? Yeah, so the solder pad's only about 3 millimeters long, so we're just going to do 43 millimeters is what I'm going to cut these to. And I'm actually going to take this and I'm going to cut all of them to the same length here. Across there. So that gives us, the length of this is going to give us the amount to bend and all that inside the frame, and you'll be fine. Now another thing, I'm actually not going to use the ground lead on the signal side. If you want, you can tie it in with the main power. In this particular build, I've run them before. I'm just going to take my wire snips, run down in there, and I'm going to just cut the black lead off. Oh, didn't get it all.
Not the black power or the black
No, just
ground.
the signal. That's the little black wire. We're going to take that out, and I'm just going to run the signals on this one. Yeah. So I'm going to do that for the other 3 ESCs. So,
okay.
All right, for the next step, what we're going to need is the 4 ESCs, the 4 motors, the flight controller, and the pigtail harness.
All right, so you got your soldering station out.
Yeah, we just need, actually, these are already...
So you just need to strip the power leads.
So we're just going to tin all the wiring we got.
And for those who don't know,
and this is more for the video. I don't normally solder like this, but this is just, I normally have a station and all that set up.
This is the station. What are you talking about?
As long as you got flux on the wire, solder goes to it really good.
But the key thing is flux.
Yeah, you're not going to want to solder without flux.
Can you solder without flux? Does it even work?
Good luck. We're also going to tin the motor leads. The nice thing about having everything cut to the right length and that you can kind of get a quick rhythm in it, and it makes everything go a lot faster, in my opinion.
Can you put too much flux on?
I mean, yeah, you can go ham on it if you really wanted to,
see
but
what happens.
It's just gonna make more smoke. Yeah, and I just had a lot of crap on it.
All right, so I noticed after you tin, you're immediately.
I'm wiping off because the flux and all that, just because it's what I got.
So that's also damp.
Yeah, and now you're not gonna want to take like the ESC and the flight controller and wiping the wet sponge and all that, but just for the bare wires, right. That's fine. Realistically, what we need to have done for the next step is the solder pads here, and I usually actually go down and tin everything that I'm going to be using, and we'll go over that in a minute. I usually tin all the solder pads first, then I solder the main leads on, then I do the ESCs last. Otherwise, what happens is you solder all that, and the current tries to, or the heat tries to transfer through all the ESC leads and all that, and all of these new ESCs are very good in pulling the heat, and then you can't get your main leads soldered on. So I always recommend doing the main leads first on the flight controller. I'm going to go ahead and do the motors and ESCs. Now, these motors are not reverse threaded or anything like that. These are all the same direction. So what I'm going to do, for the sake of keeping it clean, I'm actually just going to, the bottom side of the ESC, I'm going to leave the labels up. You can see on this build here. what we're going to do is I'm just going to solder the motor leads to the bottom, because this is not a conductive frame. That's the key feature on this frame. It's not conductive at all, so you don't have to worry about shorting anything out. You don't have to worry about reshrinking it, all that stuff, like you would with a carbon frame. So it just makes this thing a real breeze to assemble. So what I'm going to do here is I'm just going to take the ESC upside down, and I'm going to tin the leads here.
So you're going to solder the motor to the ESC outside the frame? Yeah,
I'm going to actually do almost all the soldering there, and then literally have like a skeleton or a spine
and just throw it in the frame
of all the electronics, and then drop it in the frame.
Cool.
And we'll get to that.
All right.
Tin, again, just pretty much tinning all the leads, getting all the prep work done, I think is a key here. So I'm just going to go ahead and do all these so it's easy. Alright, so I just got a little blob of solder, a nice little bump of solder on everything.
So all four ready to go, huh?
Yeah, and this is normally where a helping hand comes in play, and I don't know where
right
it
here.
went. No.
So
if you have a set of helping hands, it makes things easier. If you don't have a set of helping hands, you can actually take an adjustable wrench, just not a spring loaded, not a vice grip or anything like that. Just a open end wrench, adjustable. And you can actually hold these ESCs with it too. And basically, you don't crank it down tight or anything like that, or clamp it down tight. You just stick it on there, and it gives you something to hold the ESC.
Just enough so it doesn't move.
Yeah. And now what we're going to do is, with the bottom side of the ESC and the speed control here, or the motor, sorry, we're just going to solder everything up. And we are going to go, this one I'm going to solder everything just completely symmetrical, and I'm going to go back in the software and change the direction of two of the motors. If you are someone that, you firmly believe that's not a good way to do it, everybody's their own. You can cross the wires on two of them and just put them on the right sides, but then you're going to have to go back and check everything. It's just a lot easier. I've never had a SpeedX give me any trouble with reversing the software. So again, this is all something I've been running this frame a good bit, so something we're going to do a video on. So we're going to just solder everything up.
Even airplanes we can reverse the rotation.
Some of the ESCs don't play nice when they reverse. They cause desyncs and all that. The SpeedX, at least these ESC series, I have not had any issues with. I've never had any of my customers mention it either, so I'm going to say it's safe to do. Basically, I'm just going to go down and do the four motors there. So you just did that. And
okay. Now do that 3 more times.
Mm-hmm. Are using a helping hand, it does tend to help if you have the ESC, like wherever you're soldering, all the electronic components kind of uphill, like more vertical shaped or positioned. That way if solder does bead down, it will kind of flow into where it doesn't matter.
Okay.
Versus if you got it this way, it could flow down into the circuit under the shrink tube and all that.
Gotcha.
So it's best to hold it, more that way. I'm just doing it this way to where, I like to show little tricks and all that, so you guys that don't have all the fancy tools and all that yet, you can still do this. So I'm just kind of showing that it can be done. In the next episode of Get Her Done. Alright, so you'll see, basically by tinning everything ahead of time, it made things a lot easier. We didn't have to go back and forth. I could kind of just leave that around and just, reapply or add more solder as I needed to the iron. But it made everything really quick, so that only took a couple minutes to do there. So now we got our 4 motors and ESCs set up. So now we're going to need the flight controller. The little soft mounts here, and basically what you do is you just kind of push them inside and kind of work it around. You don't want to poke it with anything, because if you do that, then you can cut it and all that, because it's just soft, probably urethane or something.
They are a little pain in the neck to work on, but just go slow.
Yeah, it's best to do this when you don't have all the wires hanging off and all that, so that's why we're going to go ahead and do it this way. But what I'm actually going to do is I'm going to go ahead and tin everything that I'm going to be using in this build here, just to make things a little bit easier, I think, down the road. Again, tinning everything kind of helps. You don't want to have a good iron. Somewhat of a broad tip. If it's a very the pencil tips and all that, you probably won't be able to transfer the heat to the pads very well. So what we're going to do is just basically get a nice little blob of solder on all the components here.
So which ones are you doing there? Those are the main.
These are the battery leads.
Yep.
Yeah, these are the battery leads. And then I'm going to turn it around. And these are the ESC leads you'll see here. and the motor signal lead. So I'm going to do all those. I'm going to do it on both sides, and then we can go ahead and tin some of the other little ones if you need it. But those take solder very quickly, so you probably don't need to do that. But as far as the main battery leads is what we're going to do now.
So now you're going to do the ESC?
Yeah.
Times 4.
Yeah.
No, I noticed you didn't put any flux on those.
No, this is actually taking the solder very well. If you're having trouble, you can put probably just a little dab of flux, like if you really want it to.
And that's when you need to use a brush or something? I don't
a
think
brush or just whatever you got.
You couldn't dip that in there, could you?
But I'm literally just a hair to help promote it. If you really want to, you can just put a little bit. This board's already a little warm because of the heat transfer on it, so it's already kind of melting it.
So put the flux on first.
I mean, the solder probably does go on quicker, but it doesn't necessarily need the flux to transfer. This is a pretty good board. Now we have our 4 motor ESC positive negatives and the signals. So we got a total of 3, 6, 9, 12 pads soldered with solder tin here on the top side, and then we got the 2 battery leads on the bottom. Our negative on this side here. So I'm just going to lay it down.
So that looks nice and pretty. Yeah,
so you want to make sure you have nice clean solder joints, and you'll say, I mean, the board is laid out really well. If you does list the battery negative, battery plus, so you solder it according there. Then we're going to flip it around, and then we're going to solder all the ESCs up. So what we're going to do is we're just going to go around. It doesn't matter what order you do it in, but we're going to go ahead and solder all the ESCs on. You'll see that there's labeled positive, the motor number, and the ESC or the negative terminals listed. So we're just going to put it down there and see how quickly that flows on there. If you're having to hold heat really, really long to get this thing to solder, either using too cold of an iron or the tip on the iron is too small and it's not transferring enough heat. So there's that. So this is different than the old one. The old one, if I remember right, actually had both grounds to the inside and negatives to the outside. So keep that in mind when you're doing this, to definitely pay attention to the positive and negative labeling. Also, the signal wires, keep in mind these are not silicone wires. These, I believe, are PVC coated wires. So if you hold heat too long, it's actually going to start melting the insulation up there. So you want to be careful to not hold heat too long on the signal pads.
All right, so you flipped it around. Now you're working the other side.
Yeah, we're just flipping around, and we're just going to the next side here.
All right, looks nice and pretty.
So what you'll see here is this is our X-wing here, right there. We're pulling them out now. So basically, this is the guts of the quad here, and we'll be able to, once we mount some of the hardware in that we'll get into. We got to actually do a little bit of trimming with these particular motors. There is going to be a little trimming we have to do right here. Otherwise, the wires can get tear into the bell housings.
All right, that goes to the side. Now onto the frame.
All right, so the frame itself we got here. This is going to be, our flight controller is going to be oriented with the USB to the right side of the quad. So we're going to have it kind of like that. First, we're going to trim all these little spots here, and then we're going to mount the VTX. So what I'm going to do is just take this is a fairly decent X-Acto, but like a number 11 X-Acto, and you're going to go in here and actually just kind of a little at a time. Don't get too crazy because you don't want to snap the blade in your face. But we're actually going to shave this down and put an angle on it. If you have a Dremel tool with like a routing bit or anything, may work really well. I haven't tried that. I just used the X-Acto because it worked.
Looks like you're carving soap.
Basically, yeah. Well, this is our Irish Spring right here, right?
Yeah. So you're doing that to prevent the motor wires from kind of...
Yeah, otherwise what happens is with these wires, because Brother Hobby uses extra shrink tube and solder pads joints there, it doesn't flex, and you'll see on the side here what happens is it puts pressure in here, and now the bell housing is going to rub through that. It might not instantly mess up, but what happens is it ends up grounding that and shorting, and then your motors don't work.
So all four sides.
So we've trimmed all the motor lead, the grooves for the motor leads. So we're going to run the battery strap through here.
So which way is the fuzzy side?
The fuzzy side actually is going to go out, because then it's going to run through and then back over. Okay. You should see the fuzzy side on the inside of the flight controller.
Okay.
Alright, so what we're going to need is, this is a little accessory pack if you're getting the combo. We're going to use the long screws that come with the kit, and we're going to put them in here. Just drop them to the bottom. Then we're going to lock everything down. I'm just going to start just keeping my hand on the bottom side there. And then we're going to just thread them up.
All 4 go in, right?
Yeah, we're going to put all 4 in. That way we got the base of the stack. So now we got the 4 screws in here, the lock nuts there. Make sure they're, you know, fairly snug because you don't want it flopping around or anything.
Battery strap?
Battery strap's on, but not necessarily strapped down. Makes it easier to sit in this case. And then we're just going to take the flight controller with all the stuff here, because there's really nothing else to solder on the bottom of the flight controller unless you needed some other stuff. But for this purpose, we're not going to need anything on the bottom. Now at this point, if you do want to do data card, SD card logging and all that, you could cut it out to where you can get to the SD card. I'm not going to do that. I would put an SD card in it and probably just pull it off the computer there. But in this case, we're not going to use it in this build. So basically, you'll see there. And what I'm going to do is I'm going to take the wire leads and kind of just, if you want to twist them a little bit, makes it kind of a nice little curl on it. In there, and we're just going to do one at a time, put the screws in. You'll need a screw and a washer. These come with the aux frame in the little baggie. You do Loctite, you don't pour it on there, you just put a drop or 2 on the threads and thread it through. So that's going to go ahead and I'm just going to put 1 screw per motor for the time being, just to hold it together.
So you just put 1 screw in there and then go back and...
Yeah, I'm just going to go back just so the motors aren't flopping around and all that.
That's what I do too. Plus you can adjust them a little better too. You're working your wires through the little tray. Now that ESC fits in that little tray, that's nice.
Yeah, it fits in between the zip tie mounts, and we'll get to that. And the reason that you want to use these washers, because the screw heads, they're not quite wide enough. If you tighten them down really hard with a little bit of extra room, helps keep from crushing the composite material. So I got them twisted up now. I just did a single twist and run it there, but now I got 1 screw holding that, so nothing's flopping around. But we're going to go ahead and do the rest of the screws on the bottom of the motors. The frame itself doesn't seem to have any vibrations like a carbon frame. It's been very, very quiet on the sensors, especially when you're using, you know, good motors and all that. All right. So now we got our screws installed here. The next thing we're going to do is just secure the speed controls.
How do they mount down? Screws?
So, nope, we're just going to take a zip tie. Now, you're not going to over tighten the zip tie. That's key because you don't want to damage any electronics or flex the board or anything like that.
So there's 2 holes.
Yeah, there's 2 holes in the arms.
You'll see them in the aux.
And you just run a zip tie through it. There you go. Now, what you want to do is just get everything lined up here.
Your definition lined up and everything centered?
Just to where it's in the, you know, it's in there.
Okay. So basically you don't want that zip tie pulling on the...
You don't want it over tightened now. Yeah. And now this is where I was talking about, you have a little leeway with the wire. For the purpose of the video, we did a little bit long. That gives you 1 mistake extra. And
so, like you said earlier, this is touching, the bare wires are touching the frame, but it doesn't matter, right?
You'll see, if you look at this one that's not pushed down, you can see that shrink tube is actually rubbing on the motor bell housing. If I just take something, either a popsicle stick or something, obviously not metal or sharp, just a plastic blunt object or wood, push it down, you don't have any issues.
Oh, okay. That's a good look.
Alright, so what we have here, guys, is the core video here. This is the motors, ESC, and flight controller pre-assembly.
And frame. So this will be step 1, video 1.
This is the first video of the series.
Oh, I guess now we'll close it up for next time.
Yep, so this concludes the end of this video for today. Keep watching for the future videos coming in.
Part 1 of the core build, motors, ESCs, and frame.
Yep, so that gives us the first part of our video here on the AUX 215 frame. Again, specializing on the CL Racing F4S flight controller with some SpeedX 20 amp ESCs installed and some returner R2 motors.
Right, so hope you guys learned some tips and tricks on soldering. Make sure you flux, make sure you get good solder.
Yeah, just basically just kind of...
Make sure you get a good helping hand. Alright, thanks for watching and comment below of anything you want to see upcoming.